Hi everyone, welcome to our exciting course on geotechnical investigations. I'm thrilled to be your guide through this fascinating world beneath our feet. Before we dive in, let me tell you a bit about myself. I've got a Bachelor of Civil Engineering, then I chose Geotechnical Engineering to get specialized in. So, I got one master's degree by course in this field, then another Master of Philosophy, and a PhD in Geotechnical Engineering from top-notch universities. I was lucky enough to snag international scholarships along the way. During my PhD, I even developed a geotechnical test method. How is that for pushing the boundaries?
For thesis entitled Determination of Soil Plasticity Developing Mahanafi Method and Apparatus.
But I'm not just an academic. I've got plenty of hands-on experience as a geotechnical consultant too. Now I know what you are thinking. Geotechnical investigations? Sounds a bit dry. But trust me, it's fascinating. This course is where theory meets practice, and where we uncover the secrets hidden beneath the ground that can make or break a project. As civil engineers, we often face a real challenge when it comes to understanding what's going on underground. It's not like we can see through soil and rock, right? That's where this course comes in. We are going to bridge the gap between the textbooks and the real world, giving you the tools to tackle any geotechnical challenge that comes your way. This course isn't just about memorizing facts. It's about understanding the why behind everything we do. We'll be getting our hands dirty with practical applications and real-world scenarios, all while exploring the fascinating theories that underpin our work. Let me give you a quick rundown of what we will be covering over our 12 sessions. Certainly, I'll provide a more detailed explanation of each session, covering the main topics from the mind map. Here's a breakdown of the 12 sessions. Sessions 1 and 2, Introduction to Geotechnical Investigations. We'll start by exploring the importance of geotechnical investigations in civil engineering projects. We'll discuss the goals of geotechnical investigations, including site suitability assessment and economic design, various investigation techniques from simple visual inspections to complex high-tech methods, environmental considerations and their impact on investigations, international standards and regional guidelines that govern our work, the critical role of subsurface investigations in uncovering Earth's secrets and informing decision-making, how these investigations act as an insurance policy for projects, potentially saving costs and ensuring timely completion. Session 3, Subsurface Uncertainties in Geotechnical Engineering. This session delves into the complexities beneath our field. Types of uncertainties, natural variability versus knowledge uncertainty. Site characterization, model, and parameter uncertainties. How geoprofessionals approach these uncertainties using limited data and experience. The importance of subsurface exploration programs in reducing knowledge uncertainties. Real-world example of how subsurface mysteries impact everyday structures. Sessions 4 and 5, Geotechnical Risks and the Ways of Risk Mitigations. We'll take a deep dive into the risks associated with geotechnical work. Technical risks such as weak soils, loose sands, expansive clays, and their consequences. Financial risks, impact on project budgets and schedules. Case studies and statistics on geotechnical failures and their causes. The importance of true site investigations in mitigating these risks. Session 6, Load and Resistance Factor Design, LRFD, and Subsurface Investigation. This session introduced LRFD and its relationship to geotechnical work, the basics of LRFD and how it differs from traditional design methods, individual factors for loads and resistances, the crucial role of subsurface investigation in LRFD, the history and adoption of LRFD in geotechnical engineering, how LRFD balances cost-effective and safety in engineering design. Session 7, Subsurface Investigation Processes. We will walk through the step-by-step process of conducting a subsurface investigation, determining the types of data required for different project stages, the importance of reviewing available records and conducting site reconnaissance, how to craft a robust investigation plan, the risks associated with data gaps and how to address them. Session 8 and 9, Subsurface Investigation Objectives. These two sessions focus on objectives of investigations at different project stages. Project planning investigations, identifying geologic constraints such as subsidence, landslides, unstable soil and rock, chemical properties, groundwater conditions, and stratigraphy. Recognizing man-made constraints such as abandoned landfills and contaminated sites. Evaluation methods for each constraint. Design and construction investigations, identifying geotechnical performance issues for various structures such as bridges, retaining structures, cuts and embankments, pavements, tunnels, and culverts. Mapping areas of concern in 3 dimensions, understanding potential geologic variability, creating design recommendations and specifications. Session 10, Monitoring Construction Performance and Forensic Evaluations. This session covers construction monitoring techniques using settlement plates and piezometers, predicting long-term performance of geotechnical assets, forensic evaluations, identifying factors contributing to failure, data collection during construction and operation such as pore pressures, deformations, tilts, cracks, loads, strains, and groundwater elevations. Session 11, Mastering Data Navigation in Geotech Projects. We'll explore various data sources and how to use them effectively. Topographic maps and digital elevation models, soil survey reports, geologic maps and reports, historical aerial photographs, hydrological and well maps, utility maps, flood insurance maps, existing subsurface investigation reports. Session 12, Essential Site Reconnaissance for Geotechnical Projects. This hands-on session covers the importance and objectives of site reconnaissance, planning and safety considerations, key evaluation areas such as access, utilities, surface and subsurface materials, drainage, and terrain. How to prepare a comprehensive field reconnaissance report. And finally, we will have a course recap. Throughout the course, we'll be using real-world examples, case studies, and practical exercises to bring these concepts to life. You'll finish this course with a toolbox full of skills that you can apply directly to your work. So, whether you're a seasoned civil engineer looking to brush up on your geotechnical skills, or a student just starting in the field, this course has something for you. We'll be peeling back the layers of the earth together, uncovering its secrets, and learning how to work with nature to build amazing structures. Ready to dig in? Enroll now and let's get started on this exciting journey into the world of geotechnical investigations. Trust me, you'll never look at the ground beneath your feet the same way again. See you in the next video.